one is there on 19th. And I welcome today's moderator, Engineer Madhukarji, and I welcome Dr. M.U. Ashwath, our President. And then I also welcome all the participants who are there on our this thing. This is the third lecture of the four weekly webinars conducted by Dr. Ram Prakash. The first and second were fantastic, and Dr. Ram Prakash's rich knowledge and his minuscule level of detailing has really opened our eyes about what is Dr. Ram Prakash. In fact, many participants telephoned us and requested us to upload his abstract or whatever the things he explained on the web so that they can refer it at their convenient time. And we are doing that. The one is already uploaded. The second and now the third will, as it is completed, we will upload it. On these lines, we actually enthused to have another series set of weekend webinars. They are there in the pipeline under the lead by another our engineering icon, Dr. Ajit Sabnis. And this will be 10-week weekly webinar series again on every Saturday between 4:30 to 6:30 on sustainable engineering. As you know, sustainable engineering is the a very important and crucial parameter on today's construction industry. So we have taken this topic, and the inauguration and the first lecture will start from on 26th Saturday of this month, and the last one will be on 28th November. That is on Saturday. Valedictory and discussion, panel discussion will be there. Apart from Dr. Ajit, there are another 4 sustainable engineering experts who are going to share their knowledge and experience for the benefit of civil engineering professionals and student community. I request all the members, participants, students, and all the consulting engineers to take benefit of this sustainability topic, because this is the order of the day nowadays. Unless we equipped with the new things like sustainability, we will be incomplete in performing our duties, whether as a construction engineer or as a consultant or supervision or whatsoever it is. It encompasses all fields of engineering. So having said that, then it is also my duty to inform you that there is another important activity that is going on in ACCE, that regarding the professional issues harping all of our civil engineering fraternity, which relates to the ill-intentioned COA's amendment matters, and also our engineering bill. And we have taken up already these issues under the working groups of the head office issues and advocacy. And also the task force has been created from all over the centers, representation from all over the centers, and from every corner of the center, this any issue that surfaces, we are handling it from head office as well as from that individual center. To mention few of the issues is, one, as I mentioned, it is COA's ill-intentioned amendment proposals, which they want to take over the whole construction industry into their hand, and also they want to regulate the construction itself. You know, the meaning of regulation means the whole thing will be under their control, and we have to be a second category professionals, second class. Then the another thing is, still even after the Supreme Court judgment, this ill-intentioned, not ill-intentioned, the wrong way of calling the expression of interest is still going on. Although our eligibility has been proved and validated by Supreme Court, the things are being continued, and we have to stop this. So from all angles, this sustained effort is going on, and we should keep doing that also. Then bringing and passing our engineers bill in the parliament is another big issue. Unless and until we do that, we are not called as an engineers, in fact, as per the constitution. Then stopping of the quackery or quacks in the designs, in the contracts, in the supervision within the government, outside the government, in private is another big issue. We requested during the Redicon to our Deputy Chief Minister, Dr. Dr. Narayan. We requested, but still the things we have to take it forward, and it has not materialized much, but still we have not left it. We will take it to the once again to the Chief Minister's level, and quackery should stop. Because in medical field, as everybody knows, they are doing, through a task force to stop, but whereas in the engineering, they are only fostering and nurturing these quacks. So this is very unfortunate, and this should stop. So this is another parameter that we have to concentrate. The implementation of NBC 2016. See, NBC 2016 is the tool for us to implement it so as surveying, GT, all departments of civil engineering will get their due importance, and whatever their prominence was supposed to be, they will get their due. Unless and until it is implemented, civil engineers will not get the prominence. In total, we need that civil engineers only should handle the civil engineering works. That should be the total, thing that we want to achieve it. For all this to happen, we should unite. What is to be done for this unity? We have already doing under the task force, and we have circulated this Google response forms, and today also we will circulate in the webinar. Please fill it and send it back to ACCE so that your commitment will make us, to work hard and get our things due from the required government agencies. Okay, after discussing that, now it is my time to introduce our today's moderator, Engineer Madhukar, about his this thing. He is graduate from Bangalore University. Then he has a vast experience of 30 years in India and abroad. He has done lots of works in high rises, underground, in mass rapid transport systems, expressways, convention centers, then industries and airports engineering buildings, and so on. And he worked in abroad, specifically in Singapore, for more than 12 years. Currently, he is the MD and CEO of Potential Project Managers Private Limited, a leading PMC in India, and he is the founder and director of Clean Tech, Emersol Private Limited. That is providing the IoT, Internet of Things, and smart technologies to the construction engineering. He is the member of many associations, and he has associated with, at many levels with these professional bodies. He was the chairman of the INSTAG, he was member of CIDC and ICDO, that is this smart building development organization. Then he is very busy in ACCE. Then he is also taken a lot of this thing in ICI, SCWC, and FKCCI. Then there was a task force. He was active there. He was also chairman for organizing committee on international, conference on tunneling, and he has done lots of works. His additional qualifications include construction management from IISc. Then he is a lead, auditor for ISO 9001, 14001, and so on. Then he has a postgraduate diploma in quantity survey and contract administration from some Singapore institutions. And presently, he is doing again MBL of NLSIU, that is National Law School of India University. So there is no end for learning, and he is the example for us, being such a senior man. He is still having course learning in National Law School of Indian University. Hats off you, sir. And now it is over to you, to Engineer Madhukar, sir.
Thank you, Srikanth sir, for that elaborate introduction of mine. I'm humbled. At the outset, I think my duty is to thank Association of Consulting Civil Engineers for arranging this wonderful webinar series that is going to throw a lot of light on our fraternity. My special thanks also to Dr. Ashwath, the National President of ACCE. Needless to say that Mr. Srikanth and his team are doing a wonderful job of taking up issues that are affecting our fraternity. Like, for example, as he rightly said, whether it is sustainability, whether it is engineers bill, whether it is intervening in public works, enhancing the quality and experience of public works, whatever. So ACCE has, over the last 30 years, being a non-profit organization, is been doing human service, and I thank them on behalf of the entire engineering fraternity, not just myself, but also from the engineering fraternity for keeping up the good work and keeping the spirit high. And the COVID pandemic has also given a new dimension to ACCE efforts in collaborating with other agencies like ICI, Instruct, etc., wherein they are producing webinars and knowledge transfer mechanisms through web-based application. This is a wonderful initiative. I believe it is going to have a long impact, a strong impact on the community. Thank you very much. With that, I would like to move on to my main agenda, main task for the day. I've been given the enviable task of introducing Dr. Ram Prakash. I'm too small a man to give an introduction to him. He's got more than 45 years of experience, and he is very well known in our construction industry. However, for the sake of formality, I will go through his formal CV with special focus on his achievements in the last 40 years of his career. Dr. Ram Prakash is the Chief Executive of Design Consultants Bangalore, India. And he has got a PhD in Structural Civil Engineering from Indian Institute of Science, India, from in 1973, sorry. And he has got a string of associations throughout his career associated with non-profit and public interest associations. So like, for example, he was the past president of Association of Consulting Civil Engineers, past vice president, Indian Concrete Institute, immediate past chairman of Instruct, and he is the currently governing council member of Structural Engineers World Congress. He was also a former advisor and specialist to Total Outsourcing USA on enlisting, training, and overseeing project work, and also former vice chairman of National Cooperative Bank Limited. His expertise is needless to say, he's got a huge expertise across the entire spectrum of the industry, and most notably, he specializes in design, detailing, construction management, and project management of steel structures, concrete and pre-stretched concrete structures, and unconventional structures in buildings. Today, one of the topics that he's going to talk about is these structures. He's also an expert in project management consultancy and leadership in project consultancy. Some of the projects that he has designed include an 88-meter diameter tubular double-layer grid lamellar geodesic dome for the coal stacker reclaimer building near Bangalore. This project won him the Limca Book of Records as an entry in 1994. Moving on, he has also designed the total powerhouse of Almaty Dam projects in Karnataka. He also designed and detailed the fan-shaped large span roof structure of Nada Mantapa building at Mysore for Ganapati Sachidananda Ashram. He's also designed the complete expansion of cement plant for Mysore Cements Limited, designed and detailed complete expansion of Raymond Cements Limited, designed and detailed 350 numbers of petro canopies for Reliance Industries. He's also designed many concrete structures for wheel and axle plant, multiple cylindrical shells for BHEL and Travancore Cochin Chemicals Alway. He's also one of the first in the state to design architectural, structural, and services as a project consultant for the multi-storied apartment complex Ravikiran Apartments in Bangalore in 1983. Dr. Ram Prakash has been felicitated in national and international seminars and conferences in India and abroad. Most notably, he was also part of the torsion and combined torsion provisions of the Indian Concrete Code, BS 456 1978 and 2000 Code of Practice for Plain and Reinforced Concrete. He was also recently awarded the Outstanding Concrete Engineer of Karnataka 2016 by ICI Bangalore Center Ultratech Award. It's my privilege to present Dr. Ram Prakash for today's talk. At the same time, while concluding the introduction, I would also request you to note the following do's and don'ts so that the program can be conducted to the best of everybody's interest. My request number one would be to reserve your questions to the end. I had a discussion with Dr. Ram Prakash. He prefers to have the questions at the end so that there is an uninterrupted flow of thoughts from his end. Another point is perhaps he would have covered the subject or question that you have during the course of his talk. Secondly, please do not repeat your questions. I am here as a curator. I will make sure that every question that comes is captured and presented to Dr. Ram Prakash for his views. Lastly, if time does not permit, we shall make every effort to publish the answers in ACCE website if we run out of time. And lastly, limit your questions to generic interest and not specific or details, as it can be addressed separately by Dr. Ram Prakash. Thank you. It's my privilege to present Dr. Ram Prakash, sir.
Thank you, Mr. Madhukar, for those kind words. I would now start off by thanking ACCE India and the ACCE Bangalore Center for giving me this opportunity to share some of my thoughts on shell structures. And I also thank particularly Dr. Ashwath, Mr. Rajesh Kannan, and Mr. Savina, this moderator for today. This is Mr. Madhukar, who's been very, very active in all the webinars, and we have the right moderator. And I would like to thank my gurus. My biggest guru was Professor K.T.S. Iyengar, who was my guide for my PhD at Indian Institute of Science, and Professor Chandrasekhara, K. Chandrasekhara, who taught me shells in my stint at the Indian Institute of Science, and others who contributed to all my thoughts. I wouldn't be failing if I don't thank my illustrious contemporaries who have been giving me the zeal to continue with what I'm able to produce for the industry. At the outset, I would like to welcome all the illustrious contemporaries in the participants and the dynamic builders, which are a vital role, which play a vital role in shell structures, the shell enthusiasts among you, the prospective future shell imbibers, and friends, ladies and gentlemen. I would like to start off by starting my lecture. Diksha, can you lead?
Yes, sir. Yes.
Okay.
Now you are the presenter, sir.
Yeah.
Third option, share content.
Where is this?
Bottom, sir.
I don't find it here.
Share content.
No, I don't find it. Okay, share, yes. Okay,
Yeah.
right. Yeah, thank you.
Yeah. Yes.
Sorry.
Now visible.
Today's topic is varied types of concrete shell form projects and cropping challenges. It is not enough to think of a shell roof. You have to deal with all the cropping challenges along the way. You'll hear of them in my presentation. The gamut of what is going to be covered in this is some of these projects. But before I do that, I would like to pay obeisance to the following gentlemen who have been an inspiration in shells in India. First, I will start with the late Dr. T.N. Subbarao, who was with Gammon India, who was chairman, managing director. And, he used to tell me that when he joined the Gammon, as an engineer, he was always having shell in his mind. He is eager to work on the shells. And other gentlemen are Mr. Sundaram, who's from Bangalore, who seemed to have shell in his blood, flowing in his blood. Because you could see later what are the shells that he has done. And, he's a vociferous campaigner for beautiful shells in India. And Dr. Alim Chandani, who has done work in the pre-stressed concrete, and some of the shells that he has done is intriguing in pre-stressed concrete. And last but not the least, late Dr. A. Ramakrishna of L&T. He was a big inspiration and a big motivator from all the dynamic builders and constructors, more especially for shells. And I would be failing if I don't mention all the other persons whom I have left out. These are the people who inspired work on shells in India, in my opinion. I'm going to divide my presentation into the following: introduction, preamble, some shell parameters, project-specific coverage, and then conclusions. There might be some jumbling of one or the other. You'll have to bear with me. As you know, concrete can be cast to any shapes that express variety and novelty. The transition from pure sculpture to utilitarian architecture includes a great spectrum of variations. Thin shells are probably the best morphological structures to express this range through their inherent plasticity of form, which lends them to diverse expressions. Thin shells come in an immense variety of structural forms. No structural form perhaps does greater justice to the special attributes of concrete than thin shell construction. I'm sure all of you will agree with that. They derive strength from form rather than through mass. During the last few decades, the development of thin concrete shell roofs as a structural form has added an interesting chapter to contemporary architecture. The curvature of a shell can be of the same sign throughout, say concave or convex, or can be of different signs, both concave and convex at the same time. The former is called synclastic shell, and the latter is called the anticlastic shell. Now, my thoughts on the situation as it stands over the years. We have seen that we hear a lot on theories and softwares, how to design, how to detail, how to draw, write the specifications, what to be in the product mixes, how to manage, etc. However, it's common knowledge the lie of the land involves first the approach, the game plan, plethora of nuances required and circumvented, and finally the nitty-gritty of day-to-day endeavors and course corrections towards culmination of the envisaged goal, notwithstanding the egotisms of the genres involved. These are the machinations that you come across when you want to implement any of these thoughts. Add to this the need for robustness, sustenance in the built environment, economical dictates, and at times limited sections material spreads available. In India, you might be limited by certain systems and materials that might be available or affordable. An attempt is made herein to transfer some of the above to the uninitiated youngsters and posterity from the wide spectrum of the consultants' project archives as well as of others in the fraternity. Subject is addressed on the aspects of concept, design, economy, acceptability, and rigidity. What is a shell structure? Shell structure is a thin curved plate structure shaped to transmit applied forces by compressive, tensile, and shear stresses that act in the plane of the surface. They are usually constructed of reinforced concrete with steel reinforcement and outward stressing. Shell construction began in the 1920s. The shell emerged as a major long-span concrete structure thereafter. Thin parabolic shell walls stiffened with ribs have been built with spans up to 390 meters. More complex form of concrete shells have been made, including hyperbolic paraboloid shells or saddle shapes and intersecting parabolic walls. Sky is the limit. Pioneering thin shell designers include Felix Candela, Pierre Nervi, Eduardo Toronjo, Heinz Isler, and many more. Introduction to design of shell structures, range of application. The shell structure is typically found in nature as well as in classical architecture. One of the things that you can study is the leaf in a plant. Is a shell. You could see that the leaf comes in different forms, and it can withstand so many variations in the nature, and that gives you some idea about how well a shell can form by its form. As well as in classical literature. We have seen a lot of classical literature which have been done much earlier than all of us can imagine. And these are the things that are typically found. There are two principal uses of shells in civil engineering. One is for the industrial structures, where we talk about silos, tanks, cooling towers, reactor vessels, etc. And the other one is the aesthetic architectural special structures, which you come across. Sometimes they could also be something like posturing. So if we talk about shell analysis, shell can be a continuous one with curved shapes and plated structures, bending stress state or membrane stress state. There are two states to be in, or it can be a reticulated bar structure. Behavior of continuous or reticulated shells are in different forms. One is the linear behavior and the non-linear behavior. In the non-linear, you have the elastic and the elastoplastic. Introduction to the shell design. The basis is resistance and stability. These are the two important gamuts of shell design. It's highly sensitive to imperfections. One of the big things that you learn in shell construction or design are with respect to the imperfections. I will tell you about cases where failures have taken place with respect to that. Not to be afraid of these things. These are things which you have to control. Buckling is a process by which a structure cannot withstand loads with its original shape, so that it changes the shape in order to find a new equilibrium configuration. This is an undesired process from the point of view of the engineer and occurs for a well-defined value of the load. Obviously, when you design a shell, local factors are as important or more important than the global factors. So buckling is maybe due to some local effects or in general in the global effect also. The consequences of buckling are basically geometric. There are large displacements in the structure, or they may also be consequences due to the material, in the sense that deflections may induce plasticity in the walls of the structure. These are the care that you have to take with respect to the shell design. The models and methods of analysis, I just touch upon these generally. It's not getting into detail because this itself will entail a full workshop. but it's nothing to be afraid of. I mean, it's something which you have to come to grips with. You have in the models and the methods of analysis, you have the pre-critical, critical, and post-critical analysis. Then generic classification of structures in terms of characteristic instability, types, and sensitivity to imperfections. So you have this linear, nonlinear, elastic, plastic models. You have the linear buckling analysis. You have geometrically nonlinear imperfection analysis, if there are any effects geometrically, and geometrically material nonlinear imperfection analysis. If the material is different in different parts and that needs more care. Then you have the pre-critical solver methods and the post-critical solver methods. Design load checking or load deformation curves, etc. In the methods of analysis, you have these things. You have the basic equations. Then you have simplified theory, shell theories. Then you have strains and displacement that arise within the shell are very small. Products of deformations quantities that occur in the derivation of theory may be neglected, ensuring that the system is described by a set of geometrically linear equations. Straight lines that are normal to the middle surface prior to deformation remain straight and normal to the middle surface during deformation and experience no change in length. Analog to hypothesis for beams, plane sections before bending remain plane after bending. The direct stress action in the direction normal to the shell middle surface is negligible, not valid in the vicinity of concentrated transverse loads. Now, we straight away come into the parametric experiences from different case studies. One case study is my shells, which we have done, and in depth about what we came through and how they could be circumvented. The other one is with respect to the other Indian case studies in concrete shells. And the third one is international case studies. Okay. Now I start with my own case studies. In the year 1978, as soon as 76, when I finished my PhD, I was wondering why we are not doing anything in our industry from what we learn in the higher levels of learning, like Indian Institute of Science or IIT or whatever. And I was very keen to see whether something can be implemented and things like that. And the first thing that appealed to me very much is the shell as a form. So I said, let me try. How do we try with all this? As soon as I said shell, many people said it's costly, it is dangerous, it is risky, and it said all sorts of things. And then finally they said it's not possible to be implemented in India. But in 84, I went, much later that was, I saw that shell was a very common thing all over the world. But in 76, I said, I must do something about this, but what is the use of learning all about shells and not doing anything about it? So the first thing I did was, there was a water treatment plant in Alvai, near Kerala for fertilizers and chemicals. And I was doing about 12 or 15 water treatment plants all over India. And this water treatment plant is in Kerala. And I said, form work will be easy in Kerala. So can we take a simple cylindrical shell and translate it onto a project? And when I got this water treatment plant project to be done, I told the contractor that shell is a very easy thing to do, very economical, and instead of a flat roof with surki and all the steel that it requires, you could replace it with a shell and it would be more economical. The immediate thing he said was, I don't know anything about it. Only you know something about it, but you'll have to prove it to me. Then I told him, you take the project right up to the springing level. This is the springing level. You do the project till the springing level, and I will do the contract for the shell. So then I said that I would go to Kerala and then see how they do formwork and what can be done with formwork in Kerala and things of the kind. And another thing that occurred to me was these edge beams of shells are typically very big. They consume a lot of steel. There may be pre-stressed depending on the times. So I said, what can be done with respect to the edge beams? How can we economize with respect to the edge beams? Then I'd read, one of the things that you should do is, I do a lot of reading in the library, which gives you a lot of width, broad spectrum of thoughts which can be implemented. It's not a question of hearing them and forgetting about them, implementing them. And one of the things I had seen very intriguingly was this feather edge beam. If you see here, you'll see here a feather edge beam. There is no deep beam here. No, this beam is not a deep beam. This beam is a feather edge beam as shown here. It doesn't go below the bottom of the shell also. And I said that it might be economical or not, I'm not sure. Let me try it out. And in most of these cases, it's better to do a preliminary design and costing and things of the kind. Then only you can convince others. So I said I will do this with, this was something like 7.5 meter span. So I was wondering whether this would work for a 7.5 meter span. So we said, okay, let's think it over and things like that. One of the factors for people who are knowing about shells is this edge thickness. I'll come to that later, how this also has to be put in your thoughts. We got this and we started the project. So as I was saying, as soon as I started practice, I was doing what I did plan, etc. I didn't want to go to teaching, rather wanted to go to the industry. My philosophy was change the industry rather than get changed by an age-old, regimented, thumb rule governed industry doing what grandpas did. Because what I saw around me was what was being implemented, what was 25-year-old or maybe more. But I'm not criticizing, but I'm saying we have to pick it up from the level it is and take it to the level it should be. I mean, that's the philosophy with which I started off. And what better than a shell roof? Okay. Although I've done other things, but this is one of the things that I want to tell you about. Then I suggested to tenderers and contractors that I would do to tenderers and contractors, we could do a shell roof with waterproof plaster rather than flat roof with surki, especially in a rain-prone area like Kerala. Then I offered to take the contract of the shell above its springing level columns on a no profit, no loss basis. Got acceptance from all, including the PWD, which is doing the peer review and things like that. Prepared all centering detail, etc. for the shell, which was 6 meters above the top of the filter shells. Made detailed estimate of homework, etc. because I had to execute it. So, whenever you do the whole thing yourself, as though you're doing it yourself, then you'll be able to convince others, or you'll also know where to economize or not to economize. By that time, project was coming up fast and well. All the stakeholders like clients, chief engineer, tenderers, contractors, and importantly, the site supervisors saw my passion and enthusiasm, the economical costing compared to flat roof, etc., and concluded that I need not take the trouble of building the shell, but should guide them on daily basis, and they would carry it out for me. This is the way to go with your team, because they come from different backgrounds. One may be very much afraid to do anything new. Other may not have studied in depth. He may have passed his exams. He may have studied to pass his exams. But those things happen because they come from different backgrounds. So this is the great thing, that the turnaround that took place. Not that I couldn't do it. I had planned. Sometimes you should do it yourself. If you can do it for your own building, you can do it for others. I mean, that's what I feel. Now, coming to the reinforcement, is only 2/3 of flat and concrete, flat roof, and concrete was about 85% with waterproof plaster, putting the icing for me. This you could do with 15 plaster rather than put all your surki and things like that. And I have I have an experience on this particular thing for some tanks where I had put in shell roofs. The chief engineers and the minister of the government, who were because it was a big project, they were in the tender committee. The engineers had put surki on my shell and we were L1, and it was a very big thing. We were fighting with the international companies, and we were L1, and to make us L2, they put surki on our roof and said that you are not L1 anymore. Then when I faced the tender committee, and they said that you have not put surki on your shell roof, so we have put it and you are no longer L1. I laughed at it and told them that who is this who's putting surki on top of your shell? The shell itself has got a form, and the water would drain out. We have put waterproof plaster on it. We should do for this job. And when we said that, you won't believe it is the PWD minister who fired everybody, saying that what is this? I say, you don't know yourself. He is not an engineer. He was not an engineer at all. I don't want to mention his name. He was a great man, in my opinion, because such people are needed. And he said, who is this who's putting surki on that? It is well known that a shell roof doesn't need surki on that. Take it off and things like that. And then when they took it off, we were back to L1. And this is the way you face, the field is. You have to face them. Now coming to the formwork, the Kerala carpenters who are famous in woodwork were enthused maximum and carried out the work to the T. This is one of the advantages I got because it was in Kerala. And those guys, know carpentry and woodwork like the back of the hand, as all of you know. Then here I had prepared very detailed centering schedule. Then I had prepared a detailed concreting schedule, a detailed decentering schedule, especially due to the absence of deep edge beams. When you learn in postgraduate institutions, you learn a lot of all of these things. It is very easy to say, oh, just do it, everything is all right, nothing will happen, and things like that. Unless you come to terms with each and every aspect, you can't reach your goal. So this one I had prepared in a big way, and my office is a big help to me because they wouldn't be lazy. They would also want to learn, and they would also want to do. So we prepared all this for doing ourselves also. But the site engineer, what happened was, site engineer wasn't interested by all of this. He called up his friend in, I think, Calcutta or somewhere, where a shell project was done, and got news that all that was for the birds and crab. He said, just can do any type of normal centering, and can decenter any which way. Even concreting can be done with normal concreting. Nothing would happen, etc. This was a shock to me when I asked the site engineer whether he had read through all these drawings and things like that. The workers were following instructions as told by me, it seemed, but I was asked by site engineer why all this has to be followed. He said he can't do all this, and I said, you just quit from here. He went outside of site. Workers told me they'll do all. That's the key. The people who are the hands for you, they said they will do it all. Even if the engineer doesn't, they said they will do it. That day, when I was leaving the site that evening, site engineer came running to me and said, asked not to get him thrown out. I told him he hasn't learned engineering the right way, so he can't be in charge. He pleaded pardon with warning. Then came the aspect of the centering poles that we used here. The centering poles were in bamboo, as in Kerala. In Kerala you use a lot of, you don't use castanella poles. Many times you use bamboos. It's easily available and cheap. When I inspected, I found horizontal to vertical poles were connected by nails, as was done elsewhere in castanella poles. by them. It was point-to-point contact in hollow, so dicey. I asked why they don't use coil ropes, which are freely available in Kerala, which they willingly did, and the contractor was a lot of help because he was wanting to be a forerunner in doing shell roofs. In the zeal with which they approach anything new is to beat the competition. When the chief engineer asked the contractor to use, you see, everybody butts in with their own problem, with their own ideas, but you have to be very careful. The chief engineer asked the contractor to use 8 mm steel of 3 to 4 tons left over from another site. Contractor said not possible and showed it being corroded. Chief engineer was upset. Then I made an inspection. I had to tell him that it would be used as 6 mm with lesser spacing as the rims were gone. So he was a little cut up. Then I told him, otherwise we don't use that steel. Then he said, okay, you don't need steel in a shell. Why are you doing all this and things of the kind? People know halfway through. They don't learn things fully. I said, sorry, sir. I think I'll have to put my foot down here. We use it as 6 mm and things like that. Then when the project was opened, the chief of fact applauded the innovation, saying it had enhanced the looks as it was on a hillock. This water treatment plant was on a hillock, and when you drive down, you can see that very nicely with shell and things like that. So everybody was asking there, what is this new thing here? What is this new thing here? So finally, I would say that innovation needs bending of all backs and needs proper skills, as you might have observed from all of this. After we finished this, within a few years, we did a canteen for BHEL Bangalore Electronics Division on Mysore Road. And I was doing a canteen block, as you can see here. And we did the ground floor, and first floor was supposed to be for executive dining. And it would have been easy for me was simply to put a flat roof on top and finish the project, take my fees and go. When they mentioned the word executive dining in the first floor, that rang a bell with me. That first floor was 24 meter by 18 meter executive dining hall proposed to have column-free area. Earlier it was every 6 meter you would have a column. I said that we can make it a column-free area. Then I had to convince the management. I'll come to that after. Then avoiding deep edge beams and using valleys as edge beams was said to be bold and unique among shell design fraternity in Asia, if not also in the world. Because this edge beam theory was one of the things where you would have to check on the deflection of the edge beam. But as all of you know, it's just like a folded plate, and it's a V-shaped folded plate for the particular span. But we took control of that. Client Mrs. BHL accepted on condition that we furnished 3 contractors who could do the job, which we did thanks to dynamic, quality conscious and progressive contractors. It helps to know of people who are also thinking on different lines. And I was very lucky. I don't know whether it was my PhD next to my name or word had gone around about me or whatever, what have you. But surely I got people interested, and I think most of them were also wanting to be forerunners in construction. So I got 3 tenders for BHEL. This was my first bold work after my PhD for a quality conscious corporate client having dynamic management. BHEL are one of my best clients because I can get quality, they're very quality conscious and things like that. So it was my first bold work. Then I imbibed this cylindrical shell, multiple barrel cylindrical shell. And why did I do that? That is because one key thing in shells is that you have a directrix and a generatrix. For any shell, you have a directrix and a generatrix. Here, directrix is a part of a circle and generatrix is a straight line. So when you have formwork, if you have straight line generators, then it would be very easy to do shells. Not that you should do only that, but I'm saying when you are talking about nothing to be first of its kind or monument, when you are talking about economy, when you want to enter the field of competition, maybe you would have to think of straight line generators. Generator, which is the key to convince contractors. Obviously, if, he would want to do. Not that many contractors don't want to do anything else. So nowadays they're very dynamic. They come with ideas how to make the form work rather than what it was in our days when we did it all. I would wish to give a big salute to the quality contractor we got. One of the friends of mine who did this job. He was literally more enthusiastic than me, maybe, but we were friends forever. You could see this particular thing. It was column-free zone at the top. The whole thing, 24 meter by 18 meter. This is 24, this is 18. Column-free at the top. Then I was told it doubled up as a divided hall, having exclusive portion for foreign visitors and things like that, and salute all the participants for imbibing this particular thing in this project. Once I had done this shell, then I was called by BHAL to do a stores complex. And this stores complex was having a high bay, which is about 8 meters or 9 meters high, and a low bay on in the middle portion, which was 4.5 or 4 meter height or things like that. So as soon as I saw this high bay, I was thinking of the staging that you'd have to put and the cost of the staging and things like that. And I said, what could we do in this particular thing? So I thought of funicular shell for this particular thing. Funicular shell is one of the things that have been thought of by the Indian. Has thought of this. Funicular shell is one which has total compression in the body of the shell, and it is the inverse of a catenary. A catenary is something which is in tension throughout. It's like a rope. If you take a balloon and you blow it up, you get in tension throughout. So catenary is similar to that, but funicular shell is the inverse of that. You invert it, you get a funicular shell. I'll show you the funicular shell after. You could see it later. Stores complex with 8 meter high base and 4 meter precast funicular shells. I chose 1.2 meter by 1.2 meter, and the requirement was 1,200 for the complex. So I was wondering how this will all go. Will it gel in? Then grid beams provided for in situ casting. Then in this double height, grid beams had to be made. These were all precast funicular shells, all of them, which you can see in the voids here. And these grid beams had to be cast only. That's it. So centering had to be for only the grid beams. So I was told by the contractor that 50% saving was made in the centering because of this particular thing, that we had precast funicular shells, because it was only the beams that had to be supported. We'll show you a little more of that. Funicular shells cast in masonry molds, thickness 25 to 35 mm. So even the cost of the molds is a big factor, but it could be done in masonry molds, which we did, and reduced the cost. One surprising thing in this was, one of the tenderers was the smartest contractor and knew about funicular shells. For all of the people who are contractors, it's good to know what are the latest technological developments and inventions, and see where they can be imbibed. This particular contractor was really smart and knew about funicular shells, and she even quoted for it at 60% of our estimated cost. I think we had cost it at over 200 per shell or something of the kind at that time. He quoted 120 or something like that. When he came for the tender meeting, I thought this man doesn't know shells, because the other people had quoted 250 rupees per shell and 225 rupees per shell and things like that. This man had quoted 120 or 125 or something like that. I was thinking that this one will not do it. Then when he came for the meeting, he turned around and said, I know everything about funicular shells. Then I asked him how. He says, I go to SERC very often and see what new they are doing. And I have a friend of mine who's one of the directors there. So I have seen this funicular shell. It is very easy. It's not very difficult and things like that. You know how everything does in is a great thing in the construction. But PHEL insisted that shell test should be made mandatory. So they said, we said, okay, we'll test the shells. And when we tested the shell, tested the shell, which was made mandatory, showed no failure even at 450% loading. I'll show you that testing later, because these are things that you also get a feedback from. This resulted, I was told, the public sector the magazine had an article on this by somebody from BHEL. They said that the resulting overall saving in the whole complex was 11% because of this imbibing of this precast funicular shells. In those days itself, imagine now, you could do these shells in factories and transport them. Those days, all that was for the birds. I mean, they would say, no, transportation is costly, this is not possible, etc. So we were applauded in public sector magazines and fraternity and saving of 11% in cost to the country. I mean, one of the things that you get, you keep being happy about. So this was possible because one of BHEL directors and the contractor had heard about the shell through ACRC seminars. The management as well as the contractor, all along upstream or downstream the chain, all are important. It's not that when the director heard about funicular shells, he says that is known, but how can that come in here and things of the kind? And this really helps if they open up many of these organizations, open up things for people to visit and study and things like that. A lot of changes can be imbibed. Now let's see the centering part. The funicular shell centering and things like that. Notice the ease of transporting and placing of precast funicular shells and the strip centering for the beams. You can see the strip centering and things like that. Ease resulted due to trained and sharp contractor. The contractor made a lot of things, help in all these aspects. Others quoted double price for shells and things like that. Funicular shell is an Indian invention. It's an inverted catenary, as I told you, which results in complete body of shell being in compression, demonstrated in a webinar in SERC Chennai, I believe. Of course, I knew of Professor G.S. Ramaswamy. He was the chief. So, he's my great idol with respect to shells. He's written a fabulous book on it, which people should read. Now, sharp contractors elicit innovations. This is one of the key things that I was lucky in, that I was meeting the people in Institution of Engineers or any of these conferences, and they would be sharp and we would also be sharp, and they would want to know how to beat the competition. And sharp contractors elicit innovations, consultants are happy, and so are the clients. Clients are also happy. And finally, you get awarded. Here I didn't get an award, but the award was the public sector undertaking, say, reporting 11% saving in that. Just for the people who wish to know how this went through, it's like a grid roof, funicular shell roof assemblage in plan. So you see, much of the thing is all very simple. Then comes the load test of the funicular shell. All wanted confirmations. Many clients want confirmation. There's no problem if they ask you for confirmation. It is a human tendency to see whether something new is suitable for them or not. They ask for the test. Most were standing far away during test with fear. When these sandbags were being loaded, all these people who were all in the management or who were engineers, even our own engineers, they were all standing far away. They were very much afraid that thing would fall. We were below trying to look for the cracking load. We were wondering, I was telling some of my assistants, why are you so afraid? This is all in compression, and it's not a big deal. So we were trying to seeing us after a long time, after seeing 200% loading, still no failure. All the people started coming to see what it is. No failure at even 450%. The thing is that I don't wish to say that every time it will take 450%, but that's the way it was. Because if you have all the parameters right, your success or your results also will be right. The masonry supportings would have failed, not the shell. We had this masonry supporting. We felt that it's better to stop the shell test and things like that. Those days, even to take it to a lab and get it tested, they would ask more than the cost of some consultancy or whatever. So these are things which you develop along the line. And after that, we consultants got inquiries for imbibing funicular shell in their projects. People started asking us, where can we put this funicular shell in our projects?
Dr. Ram Prakash, 1 hour to go.
Yeah, sure. Thank you.
Yes, sir.
Then we came to conoidal shell, which we did for railway plant in Bangalore. And this was when they wanted a stores complex, and then I suggested that we could have a conoidal shell because it will have north light for lighting and things like that. So north light stores complex with 5 meters cantilever, loading unloading base on both sides. We had 5-meter cantilever here. Imagine this edge beam having 5-meter cantilever and having the shell there. This was won in national tender among leading lights, where one is tried crosswise. In tenders, in my earlier days, I used to participate in all the national and international tenders, and we used to be successful in 90% of them. But we would be fried by all the people who are competing or the people in the management. Although L1 in tender faced extreme heat by their existing multinational consultants who were L2, even saying we know nothing of shells and they had done similar building already in the same complex, etc. We were quizzed on total tons of steel in our design. Somebody was poking us, how much steel are you going to use, how much concrete you are going to do, which concrete you are going to use, and things like that. We were wondering what's happening for this person because it's a tender which with a total cost. So we were wondering. Anyway, we were ready for all of that. Because much of the time we do in the preliminary design itself, we do the final design like thing, and that helps us a lot to answer any of these questions. When we committed 52 tons of steel in our design, the L2 consultants found that they had used 85 tons of steel in similar existing facility. So we were made to commit use of not more than 52 tons in contract and to put requirement if more was used. The paradox of it was they said that if you use more, you will have to put the bill. If you use less, you will have to give us the steel. This is the way you're dealt with. We were told to agree, we had to commit in contract document. I said, no problem, sign it. Then made easy to execute with straight line generators. I use straight line generators. If you use straight line generators on this conoid, this formwork could be most economical. Shell edge beam had 5-meter overhangs at bottom of edge beam. Was peer reviewed by my alma mater ACCE with design in precise finite element and analysis in 3D. We finished the building in 52 tons, saving nation, if not anybody else, 33 tons of steel. That's the north light that you see. The people said that they were saving a lot on electricity because of the lighting. The next project that we got was a ferrocement shell in the St. Mary's Church in Bangalore. You could see some of these shells, sir. We suggested that we'll do it in ferrocement. In those days, this was being done in concrete, and ferrocement was not the thick thought of. And we said, why not you do ferrocement? The thing with ferrocement is you have to make the thickness uniform and things like that, and it will be very economical. And this was a ground floor project, so it would be most economical with that. So we were very interestingly having to do this particular thing, which was an experience for us. And then we got a a church project. The church was there, and we were doing work for the missionaries. And one of the fathers who known to us, he asked us what church can we build in Bangalore, And I said, I can't understand your question. He says, what type of church can we build in Bangalore? What are the types you can build? Can you please show me what we can build and all? Then I said, I don't know why you're asking this question. Then he said, some foreigners from US are coming, and they're coming for a meeting regarding discussion about this and things like that. Then I immediately said, whatever can be done in US or anywhere can be done in Bangalore. And father was really shocked. He said, is it true? I said, very much so. Then he turned around and said, the person coming from US, we'll meet him in 2-3 days, and he will talk to you, and we'll decide what is to be done. So when the person from US came, I told him, whatever is done, what is the what is the church that you want? What type of church that you want? Yes, what type of church can you build in India? I said, whatever can be done anywhere in the world can be built in India. He says, is that true? He said. I said, very true. Then I said, do you have some churches done elsewhere? If you have samples of them, I can tell you which is nice and which could be implemented here. Then he brought out a list from his distinct system, and I saw this. This is a hyperbolic paraboloid shell. So this is on 2 columns. This is 1 column here and 1 column diagonally opposite. There's no column here. This is 55 feet by 55 feet. It is a shell roof. So I proposed a hyperbolic paraboloid shell roof. Straight line generators as usual. So this is the hyperbola. And I said we could do this. And the job was on. They were very much surprised that we could do in Bangalore, do in India, what was done anywhere in the world. I mean, that's the way to be. But how I got this enthusiasm was when I landed in '84 in New York. I saw only shells all over in that airport. The TWA shell is there and all the shells were there. So I was enamored that where are we? I mean, they have implemented all this. One terminal itself fully is a shell. So I said, where are we and where are they? Things of the kind, So I said, why are we not doing this? So these were the inspirations that you see in different places. Although I told the other day, the Eiffel Tower was an inspiration in steel. And the shell roofs in New York airport was in shells. And this particular thing is what I proposed. But the paradox of it was the following. Church design, as in anywhere in the world, was imbibed. Design and detailing readied for peer review by SCRC, etc. Then they were very, 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 conscious that we should know a lot more about this than what is needed. So we were trying to do all sorts of literature review and this and that and things like that. It was not any help those days because libraries would work only from 8 a.m. to 10 p.m. and you could not take Xerox of what you want. You had to read the book there itself somewhere only in the reference library and things like that. No, you don't have that today. I mean, people are lucky today to have 24-hour libraries and things like that. Anyway, it's not a complaint, but you work under those constraints when you want to do something dynamic as this. So we had done the thing for a peer review, work awarded and readied for at site. We also got a very dynamic contractor who agreed to do this particular thing. The only thing he said was, you have to guide me on the centering, formwork, decentering, concreting and things like that. I said, we are ready. Then cement was procured and stocked at the site. Cement shifted. Then what happened? While this peer review thing was going on, it took a couple of weeks. So the contractor shifted the cement, saying that I will take this to some other site and use it and bring cement back when it is needed. And this blew the fuse and dispute followed. So there was a difference of opinion between the clients and the contractor. and it became a court case and things like that. This derailed the shell project extensively. Now it is replaced with 4 columns on a flat roof Aeron. So unfortunate end to a very nice beginning. But what I wish to say is that we had this premise that whatever can be done anywhere in the world can be done in India and Bangalore. You know, that's the motto one should have, and that's the way you should do. But there are a lot of things that you should do. You should know 200% of the subject. And when we worked on this, we were wondering who all to contact, who all to associate with construction, concreting. And you have ready mix today, you have self-leveling concrete today, and what have you. You have the chemicals, whichever way you want, and things like that. But those days, it was quite an ordeal. But unfortunate that a thing like this. But how a project could be derailed by small matters is another issue. Okay, I'll just take a few minutes to tell you about some takeaways of skills for shell proponents and technologists in India. See, after all these experiences of ours, the takeaways are that you should have full knowledge of various types of shells, cylindrical, conoid. As soon as you hear conoid, you think it's complicated. It's not. You put straight line generators, conoid is as simple as any other. Then funicular. So when you hear funicular, everybody thinks, how can it be only in compression kind? And hyperbolic paraboloid with straight line generators is another great thing. Of course, the catenaries are well known. You have these hammocks. You have a hammock. It's a catenary. You go and sleep on it, and it holds you. So the catenaries also are fantastic things about knowledge in shells. Nuances in each. In geometry, simple and practically easily executable and acceptable to existing industry levels nationally and or internationally. So I'll come to that in another project which I'm showcasing, where you had 3D geometry, getting into it, things like that. So as long as the geometry is simple, if you had straight line generators, you cut off certain aspects. If you had curvilinear in both directions, you have your job cut out. In analysis, maybe 200% knowledge and efficiency of delivery, maybe 50%. It is good to assume that you're good to assume and also recognize that your efficiency may not be more than 50%. You may say I'm 100%, but I mean that's not all. I mean, you really have to, when you get into the arena, you know that it has to be 200%. What is 200%? 200% is knowing much more than what is required for this particular thing in all ways. And what innovations are going on, what innovations are made of, and things like that. In design, it should be simple, it should be rugged, it should have articulate detailing. Sometimes even the reinforcement detailing also difficult because of the curves and things like that. Using market supplies. This is a big deal. Because many a time you design, you find in the market you don't get this, you don't get that, things like that. Fortunately, we didn't imbibe pre-stress into any of this. And if it was pre-stress, for example, in that particular shell roof for the church, I wanted to put in pile foundations, and I was told people had to come from Bombay or Chennai to do the pile. So I don't want pile. The other important aspect is to tie the foundations at the base. Which is one of the things people shouldn't forget. In construction, formwork achievability. Then you must know a design of formwork to a certain extent. If you don't know design also, at least you must know the detailing that takes place for any particular job of the formwork. Of course, now you get many system formworks and they do it for you. But many a time I've seen very few people doing formwork design, and one of my great friends used to do this in those days, used to issue drawings for formwork for his projects. As soon as he got a project, he used to do that. Economical deliverables. Finally, the thing has to gel and it has to become economical. If it is costly, nothing is going to be imbibed. Not that the economy should be the prime mover for anything. You can't be unsafe. You have to be safe first. Then in scheduling, formwork detailing for economy and sequenced release, sequenced concreting. This is very, very, very important for this particular thing. This release of centering dictates the sequence of centering. How you are going to release. You have to release in a particular pattern. International approaches and achievements imbibing national flavors in technology. Yeah, once you know how the internationals are doing it, you have to visit one of these when things are going on. No use going and seeing them when the projects are all finished. Whenever I used to think that whenever an Olympics is going to take place, you should go 6 months before the Olympics to the place, not to the Olympics. If you want, you can go to the Olympics, but you go 6 months before, you'll see what all is coming up and things like that. And I had a chance to review some of the Olympic structures internationally, in China and things like that. So you see that they are so innovative and they've gone many jumps ahead. But the important thing about this international approach is that much of the people who are behind those innovations abroad are all Indians. So I meet them. Whenever I go, I meet them and then I talk to them. Then I ask them, why you don't come and do this to India? He says, is the environment there for me to do it in India? So the environment is totally different there. The thing is, if you know the subject, you're the man for me. That's the thing. Then confidence creation in team and client and test to accentuate it. So when he says, I need 3 contractors, you will have the confidence to find out and provide them with 3 contractors. Otherwise, the project won't come up. And test, if you say, okay, how to do the test? I have experiences of tests being done by colleges or institutions. I want to, less said the better, I'll cover it some other time. I don't want to say it now, but you have to get into it in a big way in all these things. Scouting around achievements and dreaming innovations in them, if not also when possible, applauding the teams that did it. When you make a round, you have to scout around what are all the achievements made by people, and just dreaming of innovations will not do, but you should think of how they dreamt the innovation, if not also when possible, applauding the team that did it. One of the things we do is always put others down and think we are coming up. We are not coming up. We are wherever we are. So don't put others down. You see instead of seeing his negatives, you see what are all his positives. Learn from his positives and see what can be implemented. I can tell you a lot of examples of that, but that's for a different lecture. The key examples in India, if you wish to know, if you didn't know before, is the Baha'i temple and the Infosys shell. These are the 2 things that really struck me as something which is extraordinary. So I'll come to the subject of some other notable shell creations in India and then something abroad. Okay, the first thing is the Baha'i temple in Delhi. I don't know how many of you know of this temple at all. If you didn't know, I think you're not a civil engineer yet. Please visit the Baha'i temple in Delhi whenever possible. Talk about it later. Now let's look at the features of this particular Baha'i temple. I'm a big fan of this particular project, and I visited that and spent half a day and collected all the data. And I salute everybody who are involved with this. The architect was a Baha'i. Baha'i is a particular religious group. He was a Baha'i, and the structural engineers were from London, but the contractors were from India. And this job is done by an Indian contractor. You should all be proud of this. Okay, it consists of 27 petals, 9 in 3 rings. Each ring has got 9 petals. There are 3 rings in them. This third one goes up and things like that. Outer 9 petals open outwards. These open outwards. Next 9 petals point inwards. These point inwards. Third set of 9 petals appears partly closed with tips open outwards like a bud. The particular thing here. Third set rises above the rest and glass skylight at top. So there is a skylight at top. If you see the geometry, it had to be worked out from spheres, cylinders, toroids, and cones used to define precise X, Y, Z of every point on petals. I told you that if you look at the leaves or petals in a plant, you'll see how complicated it is. sometimes I keep wondering that innovator, what shall we say, the man behind these plants and trees. If you see the flower, you can see inside of the flower different color, different pattern, and things like that. I keep wondering who's doing all this up there, So, okay, let's talk about the form work. I mean, this one of the great things about this particular project is the form work for this particular. Imagine you are given this job and you thought of the form work by half. I think 90% of the people will go away saying this is too complicated. But these people did it. Erection and dismantling, to be precise. How it should be erected, how it should be dismantled, had to be planned challengingly. Doubly curved faces and closeness dealt with. They're very close to each other in many places. That has to be dealt with. Painstaking method statements with cladding features included. The method statement for the whole project had to be with cladding features. On top they were cladding. After that, we come to that. Inner form first reinforcement placed, outer form progressively as concrete was poured. They had something like a climbing formwork. It's not a climbing formwork, modular formwork, which was going along the surface here. And they didn't have self-leveling concrete and things like that those times. So they had vibrators going inside the interstices in each modular of the form, and they used to vibrate the concrete there. So fantastic is not the word. I think we got to find new words for all this. Vibrators slid through forms, no self-leveling concrete then. Continuous pours up to 48 hours and up to 22 meter height. You had this 22 meter height there, and you had continuous pours for 48 hours. Our guys did it. Our contractors have done it. I mean, all of us should be proud of this. Then come to steel. Here it was stipulated that the steel should be galvanized. One of the things I heard about this particular thing was that I was told they were designing it for 1,000 years. I'm not sure. There's a rumor saying that it is for 500 years, not 1,000 years. 500 is quite large, because I had been asked by another group whether I could build a dining hall in an ashram which would last 500 years. So that machinations are totally different when you have to deal with that. Although that prehistoric times they built things, they're still existing, but those are different forms. Galvanized steel was reinforced. Length of each bar was worked out in curvilinear profile. In this profile, you have to work out the length of each of that and things like that. Inner layer reinforcement spacers suspended from top. You see, when I visited this particular shell, they were selling a book there in the bookshop, and that was a book on construction of Baha'i temple. We should have something written for all of these, so that posterity, the engineers that are coming, younger people, get information about what all their forefathers did, or whoever did, whatever engineers did, and we'll all be wanting to go to the next step. So here you see that the inner layer reinforcements, spacers suspended from top. They didn't want it to be exposed at the bottom, the spacers, so they suspended the spacers from the top. So what all has to go into a particular project is what we have seen. Then we come to the concrete. It's a white concrete, so they wanted this to be done in white cement, because white cement was superior than grey cement. At that time, it was said to be more long-lasting and things of the kind. So I think they wanted it white also. Then they brought South Korean cement. Then the aggregate that was used for was dolomite from mines nearby. Then silica sand from Jaipur. Ice used to control temperature. Cold joints avoided by covering with tarpaulin, etc. Then the cladding. Cladding was outer white marble panel with SS brackets and anchors. Marble from Greece. This has to be marble, has to be cut to all this profile. Sizes, shapes cut to suit geometry and architectural pattern. Clever carpenters fixed 2 months before schedule. I was told when the carpenters went on the job of the cladding, they finished 2 months ahead of schedule. Then comes the project management. The project management is a dynamic construction management with high degree of innovativeness team spirit and quality consciousness in the staff and workmen. I think one of the key persons in this was Dr. A. Ramakrishna. I think is no more, but he's a good friend of mine. Hats off to people like him and his team who did this. One of the things that we should find out who did the formwork, design, and things like that, and then award them. When I came back, I was seeing what is the award this particular project got, and in the book it said Maharashtra chapter of American Concrete Institute gave second prize to Bahai Temple. If I was, what I should have been, I'd have given the Nobel Prize for this particular thing, because it's a thing. Then when I came to ACCE and said that this should be getting an award, somebody said it's older than 3 years, so we can't give the award. I said, those days I didn't want to force the issue, but in my mind, all of us should give an award to this particular project. So, in conclusion on this project, I wish to say that all contemporary Indian engineers should stand 2 inches taller as work is by Indians. Many a time it is those people who gave their blood and their toil to these projects are not thought of at all. Only a definite visit by all engineers to the Lotus Temple accentuates the awe and the glory. So I would propose that you should do. And then, very curiously, I heard that Professor Leonard, who's a famous professor on precess concrete, called it the Taj of the 20th century. He called it the Taj of the 20th century. Imagine these are the marble claddings, things like that, each piece put in place and all. And I agree with Professor Leonard that it is the Taj of the 20th century, and many people agree with that. Now we come to the shells done by Mr. Sundaram. Mr. Sundaram, as I said, maybe has shells in his blood. He keeps thinking of the shell in any of the projects, but hats off how he gets them on translated onto ground. Let's see what the beautiful things that he has done are. One of them is this one, this particular shell. I was a big fan of the Infosys shell, the shell that was done here. A big fan because I visited when the construction was going on, and the first thing I said was not only Sundaram, but the man who built it and the contractors who built it should be given a salute. And the contractor said, please go and tell Mr. Sundaram that it should be applauded. I said I will definitely will, because they were talking about 125 mm and things like that as a thickness in those forms. To get all this, you need a lot of teeth. The structures of Sundaram in the 90s and 2000s show his increase in confidence in his shell designs. This is about Sundaram, was the creator for this. The surface became thinner, and thinness of the form was expressed more clearly than in the period from 62 to earlier times. As he went along, he made it thinner and thinner maybe. Sundaram's evaluation of form may have been due to the availability of more advanced analysis techniques. But also to his increased experience with shells. But once you go and see the creations, maybe you get more confidence and you do bigger. His grasp of thin shell design is evidenced in his ability to play with the basic geometric forms, particularly in his use of folded plates and things like that. We'll come to that in another project. Difference in visual effect from Sundaram's first folded plate design at the Jayanagar shopping complex. This is where I saw his first design when he did the Jayanagar shopping complex in Bangalore. There were folded plates, there were shells, you name it, they were all there. And then the continuous study shows clearly how he has been able to use his knowledge of shells for less typical applications in visually pleasing ways. Okay. Then this is the Infosys shell, I think. You could see the thickness and things of the kind. So, in the 2000s, Sundaram's mastery of geometric shell forms became apparent. His design for the Infosys food court Bangalore, an elegant structure where he eliminated all visible surface stiffening. Truly, there is no surface stiffening. You see the form and the thickness. Truly showcasing the thinness of the form. The Infosys food court in Hyderabad also demonstrated the true thickness of the shell, but used visible surface stiffening on the interior shell surface to create a ribbed pattern. The TMA Pi International Convention Center, which he did, shows the thinness of the shell at its edge and again uses interior surface ribs to both stiffen the shell and to create visual interest. This is what appealed to me the most. You know, the formwork guys will want to have a look at this again and again. And the guys who can innovate can keep thinking about what next can we do. This is the form for the Infosys shell. And then his another project was this Contd indoor stadium, where he used precast curved shell segments. Intriguing thing was we went for a conference together in San Francisco for ACWC, and we saw on the magazine the photo of this particular project, and it was awarded the FIP award for this particular thing. So these are all curved elements which are like a folded plate. It's a curved shell, and he has used it for this Contd stadium, which has got the award. The dome is composed of 120 V-shaped folded plates, which are connected to a tension ring beam at their base and to an elliptical compression ring beam with dimension of 16 by 36 meters at the crown of the dome here. The bottom tension ring rests on 24 concrete columns which carry the loads to the pile foundation below. Dome has an interior height of 120 meters and can accommodate 4,000 people. Those are the details of the particular dome, and you can see how well a form has been used to create an indoor stadium. And you know that the FIP award is really something worth it, really. Then Mr. Sundaram has also been doing the ITC shells. He's got these shells with the edge beams. Then the interesting thing is he's done the canteen with the umbrella shells. You know, variations of shells are plenty, but he's been imbibing the right thing for the right project. And here you have on top of a building, you know, hyperbolic paraboloid shell roofs on top of a building in Bangalore, which he has done, which you can see here. So you could see that the Indian experience or Indian capabilities are at par with anything in the world. But let's all learn a little from what are all the international shells.
Dr. Ram Prakash, 30 minutes to go. Thank you, sir.
Okay, I'll be taking a few minutes only. Okay, let's come to first thing I thought of was a monolithic dome house. You know, monolithic dome is an organization, international organization, which propounds monolithic domes, and this is a house. You do this monolithic dome house, solid concrete house in 60 days. Anybody wants it. Concrete shell in 30 days, house interior in 30 days. Some are capable of even better than 30 days. Maybe not for a claustrophobic, of course. Of course, other shapes also possible in this. Sometimes even parabolic. This is circular. Some inflatable domes have also been built. These people have also been experimenting on inflatable domes. You know, with things like that. Fabric. And maybe we Indians can take this to next levels. I did a house in 60 days. One client walked into my office one day and said, "Sir, can you get me? I have to leave my house in 60 days, rented. Can you build my house in 60 days?" And in the 80s, we did it with precast folded plates, you know, in the 80s. And it was also because of the dynamic character of the contract. You know, he just used to take instruction on the phone and do the job. And we did it in 60 days and handed it over. He came later to ask for first floor. These are the beautiful examples of the hypershell. The structural strength is derived from the hyperbolic parabolic shape. It evenly distributes and direct loads downward, all in a compressive manner. Look at the slenderness of the hypershell. 6 centimeter thick concrete shell, 40 meter span, steel fiber reinforcement. The other thing is that You don't need to put reinforcement when you are talking about 6 centimeter, 60 millimeter. You can't think of reinforcement in the particular thing. So you put steel fiber reinforcement and it will job. Now I come to what was most intriguing for me of Santiago Calatrava. I was trying to get in touch with him when the last time I was in the US for an international conference in Bangalore called Nibbana. I very much wanted this guy because what I saw, what he did. Okay, let's look at the first one. It's the transportation station in New York, the World Trade Center complex. That's the station, and that's the outside of the station. This is not a painting. This is a real shot of the whole thing. Imagine what this fellow has thought of and what has been achieved. Hats off to these people. This is what we should be dreaming of in many of the projects that we do. And I also visited this Wisconsin. There was a museum. They told me that their building is like a bird, you know. So I had visited this Wisconsin thing. It is done by Santiago Calatrava. It's a museum. Articulated wing motion imbibed. This wing, it moves. It's mechanical. Is imbibed that also in this particular thing. So coming to the last part, the miscellaneous FRP, flexible and other precast form liners are coming in. If you want geometry differently, doubly curved and things like that. Inflatable forms for shells are also coming in. You could do ferro cement by having inflatable forms and things like that. Don't simply try out something without knowing the full geometry of how to go about this whole thing. It's not simple. Inflatable is something which you have to see what the initial form should be and what the final form should be. Then inflatable shells. Sometimes concrete is poured as it is, and then before it sets, it's being inflated and things like that. They've tried it all. Complete shells cast and erected. They've done this also. They've done some shells and lifted them. Nowadays, you have good lifting capacities. So this can come in a big way in some of the things, especially you have ground level reservoirs and things like that. You could put a FUNICULAR shell and lift it and place it. Shells out of steel, gridwork with clads. I am not for this very much, but you see all the airports, you have shells out of steel gridwork with clads. Shells with polymer concrete are the possibilities of the future. Now, what could be the conclusions that we can drive out of this? Sky is the limit for creations in shells in concrete and otherwise. Intelligence, hard work, teamwork, and imagination can inspire a lot more exotic and aesthetic creations with futuristic concrete portions, whether in India or otherwise. Salute the creators in order to create more and more and make living differently possible. Then is the scope for the enthusiastic youngster too among all of us. Thank you.
Thank you, Dr. Ram Prakash, for a wonderful journey right from your project in Kerala to the Infosys work and Dr. Sundaram's work, and ending up with Mr. Calatrava's inspirational work.
Yeah.
I request the participants to send in their questions now. We can take one at a time. Thank you.
Yeah. Any questions?
Any questions, please?
Hello.
Hello?
I have a question.
Yeah.
Are you able to hear?
Yeah. Tell me.
Hello. Okay. Dr. Ram Prakash, as usual, it was wonderful. But what I wanted to ask was, what is the necessity of adding fibers to the shell? Because this is a high compression zone only. The fiber addition may create problem because thickness is very small. So what is your observation of that? Is it necessary to add fibers? Without adding fibers also can we not manage? That's all.
You see, technology depends upon the current situation with respect to the material, with respect to the research on them, and in the absence of getting a material which can be good in circumstances like, for example, exposure to different conditions, you would have to think of something which has to get into the concrete to strengthen them. So it makes it a little more ductile with respect to behavior, with respect to temperature and things like that. So when it is very thin, you can't put plain concrete. You can put anything else. I mean, maybe even as we can think of polymer concretes and things like that. But we'll have to work on this a little more before we do that. So in the absence of that, this is one of the things that has been tried out and succeeded. You solved your problem for the moment. But in the future, there are possibilities of a lot of things that you could do material-wise and improve the material characteristics, and that can be imbibed there. Okay?
Thank you. Thank you.
Yeah, thank you.
Sir, I have a small doubt.
Yeah.
Sir, being very thin member, what about the maintenance and any cracks kind of a thing because of the hot sun and other issues? How you are going to address in longer span of the structure?
Yeah. The thing is that it is only the apprehension of all of us. The thing is that if you do a good job, all that is taken care of. I mean, if you get the good concrete, if you get the right concrete, if you do the concrete the right way, and if the forms are not porous, I mean, the forms are good. I wish to state that, in Europe and all that, they have rubber gaskets for the forms, so that there's no leaks and things of the kind. All this, adds up to a form which can take care of anything that you're talking about. And it's only the local loadings which create the problem, not the global characteristic of the material. So these are things which are in your hand. You can develop your concrete such that you could resist any of these particular things by a small course correction. It is not that you should have something very great about that. That's what I feel.
Thank you, sir.
Yeah.
Sir, I'm audible, sir?
Yes, yes.
Thanks for excellent presentation, sir.
Thank you.
Just I wanted to clarify how these cells will behave under seismic conditions, because our India is seismically very active, of course. By temple, I mean, we are witnessing that it is high seismic zone. How, when the design, how it will, I mean, how we will design this for under, because the forces are very, I mean, vibrant and dynamic. So how to design, how these cells behave in the under seismic conditions, sir?
I would say it is more to do with the geotechnical aspects, because these are all large span. For example, my church was 55 feet by 55 feet. So the two foundations were 55 feet on the diagonal, more than 55 feet on the diagonal, 1.4 times the 55 feet. So, how you connect these particular thing and how you take care of that would be a bigger exercise for seismic than for the body of the shell, because you're doing something on finite element. Most of the analysis is done with finite element methods. Yes. So all of that can come in with respect to seismic. But I would say the challenge is more in the geotechnical part of it. You should not mess up the geotechnical with respect to that. And all of that has been thought of with respect to Bahar Temple and any of the projects that we do. Okay?
Okay.
Yeah, thank you.
Sir, good afternoon.
Yeah, good afternoon.
My question is that, I really salute you people who are worked with shells and produced such a remarkable structures.
Thank you.
And I am Dr. Shekhar from College of Engineering, Gindi.
Oh, good.
And actually, all the aspects together has to be there, perfectly well for a shell structure. Otherwise, we miss somewhere, because geometrical things make it difficult. And I don't think many people venturing into shell structures now maybe obvious reasons, maybe that risk and all that, and they're all apprehensions. So what advice will you give the youngsters to come into this line and then do some wonderful structures like you people did? Thank you.
Yeah, I want to say that hands-on situation is one of the things that you have to imbibe in all the students. You know, the hands-on thing. You do you see that 1.2 meter by 1.2 meter funicular shell.
Yeah.
To cast one and test it out for all the things. A youngster may come out with a better use of a funicular shell than what I have thought of. You can always come through that. You can put a triangular funicular shell and do that. You know, what happens with all of us is the fear and the aura created around us. Oh, no, that is complicated. You know, that is nothing. You can't do it in India. You can do it in New York. You can do it somewhere. But why should we have that? We can do it here. You know, that sort of situation. So what we have to create is that hands-on situation in any of that. Like I was saying just a few minutes before, that what has been created has to be thrown up to all of us. So when this contractor said, I've seen funicular shells in SCRC, they were testing it and all that. See, unless he had gone there, he would have quoted double the price, and he would not have done it. He would not have come near me. You know, but it also induces how you induce all these people, but they are great people. I mean, you have to wake them up. It's like how they say about Hanuman. You have to wake them up and say, you can do this, you know. So I think the next generation is having to survive. They have to do something innovative and give them ideas and make hands-on session. You know, that is more important. Casting one funicular shell is a big thrill, and then testing it out for something else. Then another person next to him indicates some other idea for the funicular shell. Okay?
Thank you. Thank you.
Thank you.
Hello.
Hello.
Dr. Ram Prakash, the question by Mr. Prahlad is asking what is the minimum thickness of shells? Can you please elaborate on that?
There's nothing like the minimum thickness, but what you can achieve in a particular span, what you can do in a particular project. You know, if you go and tell a person who is used to large beams, and you tell him a feather edge beam, he will run away. You'll say, no, it will deflect, it will do this, it will do that. I don't want to take this project. You know, this is risky. You know, things like that. There is no such thing as a minimum. You have to develop your own. But 40 mm is what we saw there with fiber reinforcement. That is one of the minimum that I have seen. In my funicular shell, of course, I proposed 25 mm, and as usual, some of the people said make it 35. 25 is too small. If I had made 25, I think maybe they'd have said another 4% and it would be 15% sale. You know, so there's no such thing as a minimum. Once you do one project, maybe in the next project I'll use 25 mm. And the third one, I may use 20 mm. As somebody else is asking, I may put some other material. So this is the way to go, not keep on, saying, okay, because, one thing I've seen in many projects is if you have many people in the line, each person goes on changing it. For example, in the treatment plant, a assistant engineer designs it for 16 mm. It goes to the executive engineer, he makes it 20 mm. Goes to chief engineer, he makes it 25 mm. And one day they asked me, what should be for 8 meter span? What should be the reinforcement that you use, minimum reinforcement? I said, why you're asking this question? He said, 25 should be used, isn't it? Chief engineer saying that. I turned around and saw the assistant engineer who had done the design. And I just asked him, have you done the design properly? Have you seen the bond? And things like that. If you have done it, 16 is okay, 16 is okay. You can't design for bad workmanship. You have to change the workmanship to good work. So I would say you work on the situation on site, for the yeah.
Good one, sir. Good one. I think the question on, there is a similar question from Mr. Vadiraj Rao. He's saying that how do you maintain the durability of shell structures, and especially, his concern on clear cover to concrete. When you're talking about 25 mm, 35 mm, 20 mm. So I think it's a relevant question. He's asking about how do you, maintain it with regard to clear cover to concrete.
Yeah, I mean, you have these tower blocks and things of the kind that are available. It's not difficult at all. Its only question is how precisely you do your fabrication. And today you have machinery for it. So, in many places abroad, everything is from a factory. It is not done on site and things like that. But today in India, you have machinery at site and they can do what you ask. So, once it is accurate, many a time you hardly have this problem. And anyway, you have to have some of the spaces that you need to do for the cover. And that should solve your problem. Okay?
Okay, thank you. Any other questions?
Hello.
Yes, sir.
Hello, Dr. Prakash. I am Aital from Rasta. A very good presentation and appreciate the same. My question is, shall this shed technology be adopted in multi-story buildings? Am I audible?
Okay. The thing is, I don't know what to talk about multi-story building.
Yeah.
But, if you talk to a person like Calatrava or Perry or somebody, all these people, they put a full shell. They put a huge shell. And then inside, you can build anything you want. You build a multi-storied or you build a ground floor thing or whatever. So the way to build a multi-story building is to put a shell. In fact, I think in Pune or so, they've got a cladded shell space structure for a full building to control the environment. They've covered the whole thing. I think even in Bangalore they have one. So this is the way to go. I mean, you can put multi-story buildings after putting the shell. You put the dome and then you do inside whatever you want. Yeah. But if you are talking about the shell, from the shell, if you want to put flat plates or you want to put anything for the floor, you can put a shell, do the analysis with respect to having the flat floor also.
Okay, thank you, Doctor.
Okay.
Sir, a similar question, Dr. Ram Prakash by Mr. Umashankar. He's asking about, I think you partly answered it. What is the economic feasibility with respect to commercial projects, particular to terrace shell roof? I think you partly answered it.
Particular to?
Terrace shell roof for commercial projects.
Oh. Actually, the thing is, what should be done, which we do in our office, is after finishing the project, you have a look at it again, how economical it was and what is the feedback from the economy, from the technology and things like that, and learn from it and go for the next one. So you yourself will have to work out and work out the thing. But in all these things, it's the mindset. It's the mindset. If you have the right mindset, you can do whatever you want. You can achieve this. If they can do it, we can do better. That sort of thing which you can do, because most of our people are doing there, and that's the way to look at anything. Nothing can be. But when you look at that, you have to think about the settlement criteria. In the multi-story building, settlement criteria is a major factor, and also the shrinkage factors in the columns and things like that. And then when you cast the roof, cast the shell roof, the supporting of the previous floor, is a thing. Is a usual thing. And it happened with me in BHEL. When we supported the ground floor, when we did the shell roof, went on strike. The employees went on strike, saying that building is not safe, so they are putting supports. The ground floor, they put all the supports to do the shell roof on the first floor. We were told that the building is not safe. The employees told, because they didn't want to come to the canteen, in the other half of the canteen. And then I was called and I was asked, is it safe or unsafe and things like that. Then when I explained that this is a normal thing that is done in any construction, and this is especially when you are occupying the place, when you have occupied it, you have to be more careful. That's the reason why we are. Not you can remove it and you can cast, but that's not the way to do it. Then they agreed and it was all disbanded. So it's a question is other things come in. If the floor below is not designed for even the minimum loading of the thing, you can't do it in the upper floors, but you got to keep control of all of those factors. That's it.
Dr. Ram Prakash, there is a question from Dr. N.C. Balaji. He's asking about designing shells in foundation.
Well, that's a very, very nice question. Actually, beautiful question. There could be, some domical this thing forms which can be put with a stringer all around, and you could, but the important thing is the contact between the soil and the particular foundation. There shouldn't be a hollow. So how you ensure that you do an engineering fill below the thing, things like that. So it's not, the thing is that you can leave deep holes or grout holes and grout them after if you think it's going to sink and it's going to be not in contact. But it's way to take care of all those aspects. That's it. Yeah.
Mr. Patiraj Rao is asking another question. He's asked two questions, but I would like to take only one question because of paucity of time. He's asking about formworks and shutterings used for construction of shell structures. Can you elaborate on that?
Pardon?
Mr. N.R. Vadiraj Rao, he's asking about what type of formworks and shutterings are used for construction of shell structures.
The thing is that you have scantlings supporting, say every 60 centimeter or something like that, according to the curve and straight line. It's all straight line generators. So if you are a carpenter, you have the feel of the wood, you can put that, say, 45 centimeter or 60 centimeter and put a 6 mm ply on top, or you can put a 4 mm ply on top. Formwork depends on how you work the thing out. So you can reuse those scantlings for something else. So it's a ingenuity of the carpenter. Like I said, I must credit the carpenters of Kerala when I did that shell roof, because they never asked me many questions. They did it themselves. I mean, it's a real thing that when you go deep into the country, there are people who are willing to learn, willing to go to next level, and you can integrate with them and do what is required. So one has to work out by himself if he is a formwork man, or get a formwork man. Today you have system formwork. Get a formwork man to work it for you and check out how economical or non-economical it is. But most of the time it's exaggerated. You don't get into the nitty-gritty. I can give you an example of a contractor who came and he said this will cost 50 lakhs. We actually said no, I can do it for 5 lakhs. Then the fellow said not possible. Then I said you come and sit here, you're an engineer, sit with me and go through this whole calculation and then tell me. He looked at it and it was really 5 lakhs only. Then he said if it's 5 lakhs I will do it. You have to get into the nitty-gritty of it and then convince people, and they should also be able to understand what you're saying. So you have to work on it. That's it. Yeah. Any other?
Sir, I think over.
I'm just going through. There are no more questions.
Okay.
There's one question left over from Mr. Vadiraj Rao. Any special analysis required for shell structures for wind loads?
That's a very nice question. So in Indian context, you rely on your codes. You have a very good wind code, which tells you, that. But for Western countries, they usually go in for wind tunnels and things like that, and they get it so easily. I mean, wind tunnels are online with consultants. You just say this and it's done and given. But you rely on the wind codes and books. You have to study a lot of books and see what is that's why I said 200% is what I'm saying. You should know what is the aerodynamics of a dome. Then when we did a space structure, you have to study a lot with respect to what wind loading would do. It should not be just like any other loading. It's totally different. But you got to get the hang of it. Or you ask an aerodynamic man. I had a very nice professor, aerodynamics in Aero, Professor G.N.V. Rao, who was behind that wind code. So they brought in some fantastic features into that. So either you consult them or read the books, and you'll get it all. And today it's very easy, not like my days. In Google, you just put and you get 100 options. Maybe you have to pick the right option. Yeah, thank you.
Anybody else? Last two questions. Last question, please. Dr. Ram Prakash, I must admit, you've done a wonderful job of putting together 45 years plus experience in a crisp 2-hour presentation. I think you not only proved that you're a great designer, but also a good project management expert, wrapping up everything in precise 2-hour slot given to you. I must appreciate personally and on behalf of ACCE.
Thank you.
To sum up the thing, there are no more questions, I suppose. Any more questions? I think it is time, Shrikantji, I think it is time to roll up the program. On behalf of ACCE, it's my privilege to thank Dr. Ram Prakash for a wonderful presentation, taking the time to literally taking us through the evolution of shell structures in India, from the old structures to contemporary structures, contemporary design, the high shell structure, Infosys Foundation, etc. I thank him on behalf of ACCE. Coming to the larger issue of ACCE itself, I think ACCE has got a wonderful leadership team currently. Rajesh Kannanji and Shrikantji are handling the association. I would like to thank them for doing a wonderful job of bringing knowledge, ensuring that the eternal flow of knowledge is continued. Interesting to see a lot of practitioners, the professionals as well as academicians asking very pertinent and very intriguing questions on the subject. And Dr. Ram Prakash must be credited with wonderful answers. Thank you, sir. I thank all of you participants for joining and making this webinar a grand success. And I roll up the conversation by thanking once again Dr. Ram Prakash, who brought his immense wealth of knowledge spanning nearly 5 decades and made the presentation very, very conducive and very acceptable to everyone, and for his patient understanding and transference of knowledge to everybody. Thank you very much, sir. Thank you. Thank you all.
Thank you, Mr. Madhukar. I wish to thank all the teachers and colleagues from kindergarten to PhD, whom I've come through. I pay obeisance to all of them, and also to my contemporaries in the fraternity and my organizations and their members for whatever I could transmit to all of you. Thanks, everybody.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, Mr. Shrikant.
Thank you, sir. Thank you very much.
Thank you. See you. Bye.
Bye. Bye. Diksha, how many members were there?
Now 25.
No, not now.
61.
61.
Yes, sir.
Okay. Sir has given the last week's presentation, no?
Yeah, given, sir.
And this week's also it is available, no?
Yeah, sir, available.
Okay. If possible, you upload it both the things, no?
Yeah, I have to give presentation to ACCE. He only uploading website person.
From where it is being uploaded?
ಆಶೀಶ್ ಅವರು ಎಲ್ಲಿ ಅವರು ಸರ್ ಅವರು ನಾಸಿಕ್.
Oh, I see.
Yeah, we have to give information him, then only he will upload.
Okay. Oh, it has to go through HO.
Yeah, yeah.
Okay.
Yes,
Okay,
sir.
fine.
Thanks.
Thank you. Bye.
Can I end the meeting, sir? Okay.
Ah.